Hello everyone and welcome to another video. In this one we'll be working on Frustum Culling as I mentioned in the previous one. So a quick explanation of what Frustum Culling is to whomever doesn't know. So if we search for Frustum, I cannot type, Culling, we will get probably an image. Let me see if Wikipedia has an image. Yeah, so basically you can imagine that this is a world, right? And you have a near plane and a far plane, far clipping plane, and then you basically only draw the things that the player can see, right? But this is for 3D. So for 1D, let me draw, it's probably simpler. So for 1D, you have like the entire universe. Let's say the entire universe is this square, right? It's this square. But obviously the player cannot see the entire universe at once, or at least that's not really what I want right now, or at all, I think. Right? I don't think I'm ever going to need the player to see the entire planet at once. So the player is basically going to be is going to have a camera, right? It's going to have a camera. So this is basically the camera, right? So this is the universe, and this is the camera. And basically what Frustum Culling is in 2D is we only care and we only draw the stuff that is inside the camera, right? Or that the camera um, collides with. Okay, and I'm using this terminology because it's going to be interesting in some cases. So yeah, that's basically what it means in 2D. So you don't really need um, this near clipping plane and far clipping plane. You don't need any of these. You don't need projections. You don't need anything. You basically just pick the topmost point and the top leftmost point and the right bottom right point, and you can calculate everything you need from there. So to do that, I probably want to have. In the future, we also will need to work on scenes because we are putting everything in a single file, but that's not really the final architecture as you may imagine. But for now, we can keep working on a single file. So basically, we can have this draw function, and I probably want it to return an integer, and this is going to be the amount of draw calls we made in a single frame, right? So here, let me change this to also an integer because Raylib text format doesn't really like size t, so this is probably easier, right? And I can actually just move this into this function, right? Okay, so these are my terrain draw calls, and then I just need to return the terrain draw calls plus 1 because we draw the player, right? So we need to add 1 to that, and here I can just have draw calls and just call the draw function. So this is basically going to work. Okay, so if I try to compile and run, this should work exactly the same way it worked in the previous episode. As you can see, this is working exactly the same way as it worked in the previous one. We keep having low FPS because we are currently rendering and drawing the entire universe, the planet, right, with 225,000 draw calls. And this is what we are going to fix in this episode. So I probably want to pass a frustum to my draw functions, and to do that I probably want as well to have a structure. You can call it frustum, right? It is how you write frustum? I think it is. So frustum, yeah. So we can have a frustum, and the frustum is basically going to have 2 points, the left and Well, does it need to have 2 points? The frustum can just have the corner point and then have a width and height. So we can have an int x and a y, and then we can have unsigned width and the same thing for height, right? So this should probably be enough. So inside the draw function, I want to create a frustum on every frame, because the frustum changes every frame, or it may change every frame, right? And it is relatively cheap to create it, so we can do it like this. So I can basically really as a function, if I'm not mistaken, that tells us the world coordinates. Well, but do I need? Yeah, I need the world coordinates based on screen coordinates, right? So if we go back to paint, let me create a new one. Don't save. So this is our monitor, right? This is our monitor. Can draw it like this so it is obvious, right? So this is the monitor, and the monitor is going to have a screen, or a window in this case, with our game like this. We can draw it like so, and yeah, this is basically the stuff, the buttons. So this is our game, right? Okay, and the world of our game is going to be contained inside this window that is in our monitor, right? And the world is going to have its own coordinate system. So for example, if this point in the world is going to maybe have the coordinates, I don't know, like -10, 20, for example. But in the screen, so in the monitor coordinates, let's say, this actually has, this point is measured in pixels, right? So this is going to have, I don't know, something like 500 pixels like this, and 300, or for example, right? So in the screen coordinates, this is actually going to have something like 500 by 320 or something, I don't know, right? So this point has two coordinates systems, one in the screen, that is the window that is contained in the monitor, and another one is the world, that is basically the virtual world that we are projecting into the screen, right? And to calculate our frustum, one easy way of doing it is basically get the x based on the by converting the screen position into a world position, yeah, because the frustum is in world coordinates, right? So I can just say screen get it's not this one, it's the other one, get screen to world, basically, yeah. So I can get the screen coordinates into world coordinates, and here I can just pass vector 2. Well, I can say, yeah, why not, I can say top left, and here I'm going to say 0, 0, because in my window this is the top left, right? So I want the top left, actually let me point at the actual drawing. So I want to get this point, the top left, and the bottom right point, so I can calculate the frustum, right? So this is the top left, I can get the top left, and then I need a camera actually, so I can pass the camera to this function. That's not a problem, to be honest. So I can just pass the camera, and this is going to return me a vector 2, right? So this is basically my world, top left, right? And this is my screen. Well, what is, oh yeah, this is my screen top left, right? And this is my world top left. So I can do the same thing for the bottom right. So if I change this to bottom right, now I actually need to get the x and the y, and that's easy to calculate because this is just the screen width and screen height, basically, right? So that's relatively easy. You can just do get screen width and get screen height. So that's it, I think. Then to basically calculate our frustum, we can just do, so the x is going to be equal to the same x from the world, and the y is going to be the same thing. Then the width is going to be the difference between the x of the bottom right and the x of the top left, right? Correct, and this is always going to be positive, right? Because width is always unsigned. And this is the same but for y, right? And this is height. Okay, so I think that's pretty much it in terms of frustum. I don't think we need anything else. So here we can just pass the frustum, and this now is frustum. This function it's meant to be agnostic, so these draw calls are going to be removed from here in the future, but that's why I'm passing the frustum directly to here, right? Because I don't want this to be dependent on raylib, to be honest. But yeah, so we have the frustum, and we know this is a grid, right? It's a grid of tiles, so this is super easy to cull, right? To do some frustum culling in it. We can just do, oh, actually here we actually want something. Okay, we must not forget, since we are in a grid, right? So we have this grid. Let's imagine some tiles. So we need to not forget. So let's say imagine that I have that point, right? How is C going to cast a float into an integer? Is it going to round up or down? I'm not really sure, to be honest. I think it's just going to truncate the number, so that's fine, right? For x and y, that's fine. We can truncate it without any issue. But if I have something like this for the top, for the bottom right, then I actually need to seal it, because I actually want the full grid square. I don't want to truncate it, right? So this, we just need to be careful with it, because here I actually need to seal, right? I need to seal it, seal F for floats, right? So I can seal that. Okay, and this is okay, but this is going to, okay, I don't know how this is going to, but even if this truncates it, that's going to work, I think. And here it's going to then truncate it, but this is the width, right? Let me think. I probably want to convert this into integers just to be sure, right? I don't want to, even if it's not necessary, I just want to be sure it actually works, right? Because I'm not really sure how this is going to actually compile, right? The casting between floats and integers. So yeah, I think that's enough. So here we can pass the frustum, okay? So we pass the frustum, and inside here we now know that we have a top left corner, and then we have a width and height. So we can start rendering from our x, right? From the frustum x, and we only need to render. Do I want my screen to wrap around, or I want to wrap in the future, but for now, to test terrain generation, that's basically what we are working on. I don't think I want to wrap it, because it's easier to visualize how the terrain is being generated without having like terrain wrapping. So I think I'm going to leave this condition with two things. So this needs to be less than planet width, and x needs to what am I doing here? Basically frustum x, well, I probably want to calculate an index just to be, yeah. So this is my start x, and so this is my end x, just so I don't have to calculate this every single iteration, because this is a constant, right? So I can just do that. So basically x is less than and x, right? And here I can do the same thing. I can calculate what am I doing? I'm also always mistyping. So here I can probably say the same, but for y. So this is first term beginning I, and this is the height, right? And x is less than and y. And I probably want to be less or equal, actually, because the last x is still contained in the first term, right? So I want it to be less or equal. So I think that's enough. Yeah, so let me just do a simple trim. What is it complaining? Oh, because this needs a camera. That needs a camera to calculate the frustum, and I think that's it for now. Previously we had 225,000 draw calls. Let's see how many draw calls we currently have. We basically dropped it to 20, well, yeah, to 35, 20. Okay, but this is not really draw. Okay, did I swap something? Because this is rendering the x as if it was like a y. So this is height, I think. Did I miss? Did I think? That's very strange. So this is screen width and height, that is correct. This is bottom right. Yes, did I make a mistake? Oh yes, of course I did. I forgot to do frustum y, and this begins like this. And this is actually y, this is not text. What did I do here? What? Okay. So let's actually compile the correct version now. Okay, so this is not the correct version, and as you can see, the draw calls dropped from 225,000, almost 226,000, into 2,500 more or less, right? And as you can see, as I move my player, depending on the terrain shape, we are going to either do more draw calls or less draw calls, because as you can see, the terrain is irregular, and sometimes we don't need to draw as much tiles as previously. For example, here is a point where you're actually drawing a lot of stuff, right? 3,000 draw calls. But if I go lower, we're actually going to fill the entire screen, and this is the largest amount of draw calls we can perform. That's basically 4,400 and something, right? Yeah, 4,401, and so on and so forth. Okay, so I think that's basically Frustum Culling in its essence. As you can see, we were able to drop the draw calls from 226,000 into just over 3,000, in just less than 3,000 actually, right? So yeah, I think that's pretty good. And if we disable this FPS limit, or actually if we put it to 600 or something, we should actually have a huge amount of FPSs, right? As you can see, like I'm navigating through the terrain, and I'm constantly getting 500 FPS, right? So this is the large benefit of Frustum Culling. We more than 10x the FPS, and it was super simple to implement. Alright, so I think that's everything for now. In the next video we will continue to work on terrain generation, or maybe, well, do I want to? Yeah, I probably still want to work on terrain generation in the next video. Maybe caves or something like that. And in the next one, after the one after the next one, I probably want to start creating config files to store all of these little parameters for terrain generation. And I'm probably going to use JSON or something like that. But I'm going to implement a parser from scratch. And yeah, I think that's everything. So thank you for watching, and I see you in the next one.